In question 4, the chemistry jumps back to organic chemistry, and we've got a couple of mechanisms that we're going to have to explain. So the first one is the reaction between propane and I Br. So a little bit nasty here because we've got HBr in our notes, and some students might be thinking, well, I've not heard of IBr. It's just the same, it's going to do exactly the same thing as HBr. And we're told that one of the products is 2-bromo-iodopropane. We're given that there, and we've got to suggest the mechanism for that reaction. So we've got the first part of the mechanism, we've got our IBr, they've already polarized it for us. So we have a curly arrow from the middle of that double bond to this slightly positive iodine, and that will obviously repel the electron pair in the IBr bond onto the Br. So we need to draw the correct intermediate. Remember, this is called a carbocation, and because the iodine has got to end up on this carbon, the iodine is going to add first, so we need to stick it on that carbon there. That means a positive charge on this carbon. The bromine will be in the form of a Br minus ion, so we could either do that, or we could put the lone pair on and go like that. Remember, the curly arrow must go from either the minus sign or the lone pair. Name of the mechanism, electrophilic, spelled properly with no double L at the end there, single L there, electrophilic addition. The other possible organic product, well, if you'd put your iodine on that carbon and the bromine on that carbon, you'd have made something different, and there's the structure of it there. And then we're asked, or we're told, that methane also reacts with IBr. Remember, methane reacts with Cl2. That'll be in your notes, I'm sure. And we're told that it forms many products, two of which are iodomethane and HBr. So I've just quickly sketched them up there. Suggest the essential condition needed. Well, that's going to be ultraviolet, because that's how you get chlorine to react with methane. And this is very similar to chlorine, it's two halogens covalently bonded together. So all the time just be thinking, well, I've got this in my notes, so maybe it does that. And of course it will do. The mechanism of the reaction involves 3 steps, one of which is called termination. So we've got to describe the mechanism and include these various points to our answer. So I'm just going to knock these off straight away. The name of the mechanism is radical substitution. The names of the other steps, well, they are initiation and propagation. And we'll talk about the mechanism for those in a second. And the type of bond fission that occurs is homolytic fission. And then the other two things, the two bullet points will come out in the rest of the answer. So first step is initiation. So that's where the IBr is attacked by the UV light. It's going to break the covalent bond between the iodine and the bromine. Each atom or each particle receives 1 electron from that covalent bond. So we produce these free radicals, and that's why it's homolytic fission. Each particle receives the same number of electrons from the covalent bond that's broken. The second step is the propagation steps, and remember these occur as a pair of steps. So just remember we need to form CH3I. That's important. So we're going to use the bromine radical to take a hydrogen off the CH4 in the first propagation step. That's going to form a methyl radical and an HBr molecule. So in propagation steps, remember, we've got a stable molecule with a radical forming a different radical and a different stable molecule. And I suppose we could go back to initiation with something similar, stable to 2 radicals. Just little ways to remember what's involved in the steps. So part 2 of propagation, step 2, the methyl radical, the new radical that's formed, would then react with another stable molecule, radical stable, and that's going to generate the CH3I that we were told we have to make. That'll form also a bromine radical, and that's your pair of propagation steps there. And then we had to come up with another, or one of the termination steps. There's lots of possible answers. So you could have two methyl radicals making ethane, two bromine radicals forming bromine, two iodine radicals forming iodine, or an I and a Br radical forming IBr. And I think, yeah, that's the end of the question. The quality of written communication mark there, whenever you see that pencil, they're after your use of correct sort of scientific terminology. They're going to be looking for spellings and that sort of thing. They wanted you to link the initiation and propagation steps to the correct equations.